I want to give a big thank you to the BioMADE team for inviting me to provide some remarks for this. I'm sorry I'm not there in person, but hopefully next time. At Schmidt Futures, we're bringing together the brightest minds to work on the hardest problems. And we connect people across fields, we bring some capital, and we try to solve real hard problems and get things built. And biology is, of course, this extraordinary field that is now about to explode in all sorts of interesting ways. We have been working on AI and synthetic biology for a while, and we're going to basically announce our partnership with BioMADE and talk about a way to get into this estimated $4 to $30 trillion industry around biotechnology. And we, the United States, are the world's leader in synthetic biology, but if we don't, China and others will catch up. So the time's now, the investment's needed, and we need to get very focused, which is why what you're doing is so important. We released in April a report, which I hope everybody has read, which basically is called the US Bioeconomy, Charting a Course for a Resilient and Competitive Future. And I want to give you some sense of what it talked about and why I became so excited about it once we sort of assembled all the possible scenarios. Many of the task force members are in St. Paul with you guys now. Now, synthetic biology, of course, is already discovering new technologies to drive this fast-growing bioeconomy. So to me, it matters because it can solve many of the hardest problems that have been bedeviling us for a while. So imagine, for example, a new generation of plastics that degrades to harmless compounds in seawater and soil that can be easily recycled. Alternative sources of food protein, right, for all the obvious reasons, starting with the issues with cows and methane and less water and land and all of that kind of stuff. And soil microbes that reduce fertilizer use, right? Improve the health of soils, improve carbon and remove carbon dioxide from the atmosphere. My point is that you, the BioMADE community, are at the forefront of this. And what you do will, to some degree, determine the course of the world's future. Because if we don't solve these problems with biology, my guess is we won't be able to solve them at all. In other words, we don't really have a choice at this point. I don't see another scenario. Now, you all already know that synbio is exploding. Millions of compounds are being built. 60% of the estimate is the current estimate of materials that we use that can be grown instead of manufactured. CRISPR, of course, allows us to turn on and off genes, and mRNA development alone, which is a positive effect of the terrible pandemic, generates sort of 50 years of innovation. So we're digitizing data, we're putting everything together, we're putting things into these large data sets. And because of language technology, we're building these large language models. We're on the forefront of building systems that are incredibly powerful at scale, and that matches well to the biological problems. What we're doing is we're doing lots of things around, at Schmidt Futures, we're doing a lot of things around AI. For example, we announced a program called AI 2050. AI 2050 is to imagine if everything went right by 2050, what would the list be, and how do we make sure it gets right before 2050? And that includes things like the hard technical problems of resilience, brittleness, and bias, and so forth, but also the effect on society, the issues of jobs and national security, and what does it mean to be human? We've also been funding targeted AI plus X for some X, where, for example, many hard science problems are lacking the computation of a particular function, which is incomputable with today's technology. AI can be used to essentially generate that function. If you have inputs and outputs, you can simulate or create that function enough for the scientist who's a chemist or a physicist or whatever to solve the problem, make the breakthrough, and figure out what's next. Now, all of this, the exponential growth and the widespread use of machine learning is something that's going to happen no matter what. And that creates this platform that we collectively can begin to work on biology and synthetic biology at scale. Now, we estimate that this is a $4 to $30 trillion annually business. And it makes sense if you think about it. If you assume that synthetic biology is not just crazy drugs, but it becomes concrete and steel and plastic and food and fertilizer and all of the other things that we care about, all of a sudden a new course of manufacturing will happen. Now, in my view, I think that we're going to become, in the next 20 or 30 years, a fully biotic civilization. By that, I mean, we're going to harness biology in such a way that we can use the natural or God-given, if you will, invented systems to do things which are hard for us and easy for biology. And I think, we've sort of learned that we will learn by 2050 for sure that we can grow whatever we need and whatever we need enabled by ingenuity and technology, which is what you all represent. So I don't think that this is a long Cambrian explosion. I think it's a short Cambrian explosion. What will happen is boom, right? All of a sudden, this technology will happen. And the reason I say it's going to happen with a boom in a good way is that biology is built for scale. And so once you discover these things, it naturally scales. So the specific example I want you all to think about is think about where all the biomass is. And the biomass is pretty well distributed around the world, but in particular in the US in sort of more rural areas. And imagine that all those empty factories that used to build things can now be used to do the equivalent of the reactors, the microreactors, the breweries, if you will, to take all that biomass and turn it into stuff that's useful in the state, in the region, and in the nation. When this happens, all of a sudden, those areas which are today having economic trouble will see both the power of what we can do, but also will come to respect the science of what we do. And that's very strategic for lots of reasons in our political conversations. So we need to make this transition as a country. And I think that we're going to, as a country, get all of the benefits quickly if we move quickly. Sorry for the alliteration. Reduce our dependence on fossil fuels, revitalize US manufacturing in the way that we're talking about millions of jobs here, by the way, create more resilient supply chains because it's just easier. Resilience comes naturally in a biological sense. And then this, of course, addresses our questions about national competitiveness. So when we released this US bioeconomy report, I think it was the first time since 2012, people had put together an integrated strategy along these lines. And you're welcome to take it, extend it, copy it, complain about it, and what have you. But it says that if we get our act together, and in this case, it means a couple $2 billion of funding out of the US government, a lot of private philanthropic work, but the majority of the funding comes out of the commercial sector, which is how America works. And so if we get this right, the US, the government can provide some seed funding. We and people like myself can provide the necessary starting funds. But then as this thing works, enormous amounts of capital and jobs and scale come. And that's sort of how the American model works. And I really, really like it. So we specifically call out for a couple of things. We need an official home for a bioeconomy in the United States, in the White House somewhere, presumably. That obviously can be discussed. We need to dedicate a couple billion of new funding for science of scale research. The problem today is they're building these little reactors, and the little reactors work great, but they don't scale because these are living things. And we need to figure out how to solve that problem. Infrastructure. Turns out that flexible manufacturing test beds that are essentially the term, the economists call it pre-competitive, is really important. And these test beds can be designed for sort of maximum flexibility, allowing you to move quickly. What we learned with iteration in other industries is that you need places where people can try something, and boom, it works. And the quicker that cycle, the quicker the innovation cycle. And the combination of the scale research and infrastructure should allow flexibility for a lot of things, including future pandemic research and things like this. We also, and this audience I know agrees with me, we need to fix it so that we can get STEM graduates from around the world who want to come to work in the US, build companies, pay taxes, create jobs, and so forth. I've always thought this was the stupidest idea in the US government, that we don't allow these people to come. We bring them into our country, we educate the heck out of them, and then we kick them out to go create competitors in other countries. Not a good strategy. Let's fix that. The DoD, right, is also working hard on this. They supported the first biorelevant manufacturing innovation institute in 2016. And I turn out to be now a member of the National Security Commission on Emerging Biotechnology. And I can tell you, without going into the details, that the DoD is taking this set of issues extremely seriously. the issues of misuse are just as important as the scale of what I'm talking about. We need to get both done, and I'm confident we can. So in our case, in Schmidt Futures, we've created something called the BioFutures Group, which I'm very proud to say Mary Maxon and Andrea Hodgson are leading. And we are going to put our money behind the kind of stuff that I'm talking about. We're very, very interested in how to repurpose sustainable biomass and how to overcome these engineering constraints in these reactors. And basically, if you don't solve those two problems, you don't get to scale. And by the way, there's always problems, right? That's what innovation is all about. So it seems to me that we're going to do things like, and we're now funding these new innovative hardware engineering solutions to improve manufacturing processes to get to market faster and do the science of scale, investing in the next generation technical talent for the obvious reasons, and investing in basically the science and the strategies around waste carbon, right? How do we use it? How do we get it in? How do we scale it? And in fact, today we're announcing a $10.5 million partnership with BioMADE to improve bioreactor innovation, right? So thank you. You guys are going to do the work. I'm really happy that we can do this as a partner. So while there are millions and millions of dollars that are invested in optimizing microbial factories to increase their production efficiencies, these are not designed for the newest bioreactors. So we have these incredible microbes, but we don't have the correct bioreactors, and we need to get that fixed. I think we can get that done with our partnership fairly quickly. Thank you for listening to me. Thank you for letting me appear by video. And I really look forward to what you're going to do and the partnership we're putting together. And thank you again.